All right, class. What I've done, I went ahead and did that calculation for you. So I take the mean of group 1, subtract the mean of group 2, and then I'm looking for the variance of group 1, and I'm going to add the variance, and this is called pooled variance, of group 2. I'm going to divide this by the numbers of observations for group 1, the numbers of observations for group 2. So I'm going to keep coming down. After I do this calculation, I get a negative 13, and now I get 21.909 from this calculation here, and from this calculation of 65.4 divided by 11, I get 5.945. Then I'm going to add those two together, and I'm going to come down here, and I got negative 13 divided by the square root of 27.854. And then when I take the square root of that, I get negative 13 divided by 5.277. And when I do the math on that, I get an overall t statistic. We call it a t observed of negative 2.463, which matches our outcome here of our t stat, which is 2.463. So you can do it by hand or you can do it by the Excel. It's up to you, whatever you want to do. So hopefully I have explained this well enough so you can do the homework, because I'm going to go ahead and assign the homework for you. And if you have any questions, please let me know. I will go ahead and make sure that you have plenty of time to do this. I'll probably go ahead and start making some new videos to cover the ANOVA, which is also in chapter 9 as well. So if you have any questions, let me know, and I'll definitely help you out on this to the best of my ability. Remember, it's just anytime we're trying to compare means of two groups together, and a lot of times you will do that. You'll look at different stocks or something like that, or they're moving in the same direction, or you may come up with a some kind of intervention, or you may make something, some kind of fuel additive or something like that you say that it's going to be better than a normal car using just regular gas. So that would be your independent and dependent variable. So let me cover that real quick. An independent variable, we'll call it the IV, and the DV. So the DV will be the dependent variable. So the independent variable is anything that I do, like an intervention, that will have an impact on the dependent variable, which is what I'm making a claim. So over here with my hypothesis, what I've done, I said that class 1 over here is going to be lower as far as their scores go than class 2, because I'm giving class 2 an independent variable or an intervention. And that intervention is in the form of video enhancement. So I'm giving them, lecture videos and classroom, videos that will enhance just the regular class. This class did not get the videos, but this class did. So I did something, and I'm going to measure on the dependent variable, which is their grades. So I took 11 students here at random, and I calculated their final exam grade, and I said that this class here would be higher than this class, or this class would have lower scores than this one. Same thing. So my independent variable over here for this particular experiment is going to be video enhanced learning. This class got videos, this class did not. My dependent variable is what I'm measuring, and this is going to be final exam grades. So the final exam grades for group 2 were 87, and for group 1 they were 74. So when I use this particular statistic, and I have to use this statistic because the conditions are right. I have two independent groups, and I have 11 observations here, or 11 scores. So if I had 30 scores or more, I can use a z-test, because then the distribution is going to take on the characteristics of a normal distribution. So I can go ahead and do that. But since I don't have those conditions, I need to go ahead and use a test statistic that's appropriate for my data. And in this situation, it is going to be the t-test. And that's what your homework's going to be over. So I'm going to give you something very similar to this, and you will go through the steps, and hopefully that will help you understand why we use different methods to test a hypothesis. So the next one we're going to look at, it's going to be called an ANOVA, which is an analysis of variance. And when we use that one, we'll use that anytime we have 2 or more groups. So usually if you're testing the means of 3 or more groups, you definitely use an ANOVA rather than do multiple t-tests. So there's different characteristics for that particular test. So we're going to go ahead and cover that. And then subsequent chapters left in the book are going to be correlation coefficients. And then we'll end the group of the semester with the chi-square distributions and chi-square tests. So you're going to know when to apply these different test statistics and what conditions you're going to need to use these, or at least you're going to be aware of when someone else is using these. Okay, I hope this is good information for you. Again, let me know if you have any issues or trouble with this, and I'll definitely help you. All right, good luck on your homework, and let me know if you have any comments, concerns, or just if you want to talk about stats or whatever. All right, have a good week.